Guys, hope that you are doing well. So today we will discuss about the topic of mechanics of solid, which is the about short prismatic members. Okay, what is prismatic member? A prismatic member acts upon by just torsional movement will experience only torsional behavior. Okay, uh, basically prismatic member, uh, why we need on a column or any type of beam when force applied at any corner which make torsion in his body. We know that torsion basically a rotation from one side. Okay, then the cross sectional will just twist. Okay, our body will be twist, so we can say that our member is prismatic member. Mechanics of solid text deal with stresses and strain and bending. So that's how we use and calculate our stresses in any type of beam. Okay, short prismatic member, just like body. You can read this theory just like body. It's a body. We know that the corner of body, the force will be applied P, and EY and EZ is the distance from its central axis, which is eccentricity. Okay, so here we are discussing in detail. With the help of example you can clearly understand. It's also if we apply at here the force, then definitely body will twist. Okay, this is our example. T-shaped beam, we apply the force P from this corner. So for given short prismatic member, locate NA. NA is basically neutral axis. Calculate stresses at point A and B. We have need to calculate the stresses at point A. A is this and B is this. Okay, so initially we find area. We know that area 60 into 10 and 10 into 60. Okay, 50. So simply y bar is centroid. How we can calculate centroid? The area of first body, 60 into 10, 600 multiplied by 30. What is 30? 30 is the distance. Now basically how, if we can see, this is 10 into 60, 600. The distance from it center, start from it central axis, is 30. So here I deleted my red border, and here is 10 into there is 500, which is 65. 60 and half of 10 is 5. So divided by area, and same as it is, this is the IZ. How we can calculate IZ? We can calculate by moment of inertia. Moment of inertia, BT cube divided by 12. What is breadth? Breadth is 10. Okay, depth, what is depth? Depth is 60. Okay, depth is 60. So we calculate, basically this is about body 1 and this is about body 2. This is have about body 1 and this is have about body 2. Okay, so this is 10 into 60, 10 into 60 divided by 12 into 600. 600 is basically this one, and 45.9 minus 30. 45.9 basically your distance, and 30 we know that 30 is basically its center. Okay, so the distance from center to its neutral axis of body. Okay, So 30 is the half, and 45.9 we know that we have divided this value. So same as this second value. And iy, how we calculate iy? It's 16 to 10 cube plus 0 plus 0. Basically it's for z-axis, and this is for y-axis. We know that y-axis is 0, and same as it is. This is simple. If you are confusing this property, you can go to my channel and also search geometric property of body. So here I have also clearly explained by manually as well as by softwares with smart work. So what is eccentricity load? Eccentricity load is the distance from 24.1 to 10. If we can minus 10 from this load, okay, so the remaining distance from its neutral axis to P point is eccentricity. Okay, Ex and Ey is same as it is. We have calculated 50 into half. Basically Ey is vertical distance and Ez is basically its horizontal, and we can say third axis. Okay, so which is half of 30 from this. Okay, eccentricity we have also discussed about here. Okay, so now we are just putting the formula of combined stresses. Prismatic P is basically a load which is given in question 100 kilonewton, and P, and same as it is Ey eccentricity we have calculated at here, and Ez also Ey and Ez, Iz and Iy we have also calculated at here. Okay, so same as it is, we make a general equation. So now we have need to more clarify the variable of y and z. So we make this form. Okay, so now we have need to take distance from neutral axis to point A, point B and point B. We just put the distance in y and x, so we take the value of combined stresses. Okay, here is clearly view is, and it is our general equation. We just need to find the distance of y and z. Automatically we calculated the stresses. Okay, this distance we know y is 24.1. This distance 24.1 for plus and for minus 25. We know that half of 50. If we are going to right, then it right from neutral axis, then it is plus, and it from left side it negative. Okay, so we are taking right and positive, and same as it is the sign conjugation. 14.1. What is 14.1? 14.1 is basically 24.1 minus 10. It's a distance which is we have used previously at here, this point. Okay, so same as it is 45.9 is basically this simple clearly view. Okay, so now we clearly see the stresses in every corner point of our body. Okay, if you have any query, you can comment, and also if you like video, and share the video for more thankful and regard. Okay, thank you.